So in this problem, we're looking at a situation where the left-hand side is in a factored form, but we have a term, or sometimes terms, multiple terms, on the right-hand side. So what do we do in those cases? We can't use the zero product property because it's not equal to 0. Well, the process is the same. We just add a couple extra steps. We want to get this into standard form. ax squared plus bx plus c equals 0. In order to do that, we're going to have to multiply through here and then combine like terms and simplify by subtracting the 12m from both sides. If we just subtracted the 12m from both sides in this form, well, then we'd have addition or subtraction on the left-hand side, and then we couldn't use the zero product property. So the first step is let's multiply these two binomials together. If we use the FOIL method, 2m times 3 is 6m. Or let's start with the first terms. I said FOIL, but then started using the distributive method. So 2m times m, that's 2m squared. Outside, 2m times 3, that's plus 6m. Inside, 1 times m, so that's plus m. And then 1 times 3, that's plus 3. That still equals 12m. Combining like terms, we end up with 2m squared plus 7m plus 3 equals 12. Now subtracting 12m from both sides, we get 2m squared. 7m minus 12m is going to be minus 5m plus 3 equals 0. And now we want to know, okay, how do we factor this? So again, we can set this up. If you need to review factoring, go back and review factoring. This isn't a special form. It's not a perfect square trinomial. It's not a difference of squares. So instead, we need to factor by trial and error. But we can set this up to give us a little bit of knowledge. 2 is a prime number, so we know that the only factors are 2 and 1, so we're going to have 2m and m leading. And then with a positive last term, the 3 is being added, and a negative middle term, the 5m is being subtracted. The only way we're going to end up with that is if we have 2m minus and m minus something. Now, from this point forward, it's going to be a matter of using the factors of 3 to determine what combination we need, what we need to subtract in each binomial. Using those different possible combinations, what we'll find is that 2m minus 3 times m minus 1 is going to give us this minus 5m in the middle. So if you look at this, 2m times m, that's 2m squared. Outside, minus 2m. Inside, minus 3m. Minus 2m minus 3m is minus 5m. And then negative 3 times negative 1 equals 3. So now we've got the factored form of the entire quadratic, and we can use the zero product property. We know one or the other of these binomials equals 0 because that's the only way the product will equal 0. So 2m minus 3 equals 0, or m minus 1 equals 0. Add 3 to both sides and divide by 2. We get m equals 3 halves, or m equals 1. And now we will check our solutions by plugging back into the original equation. So we'll start with 3 halves. So 2 times 3 halves plus 1 times 3 halves plus 3. We want to know, does that equal 12 times 3 halves? So 2 times 3 halves is 3. 2 divided by 2 is 1, which leaves us with 3. Plus 1 is 4. 3 halves plus 3, that's going to be 3 halves plus 6 halves, which is 9 halves. So 4 times 9 halves. We want to know, does that equal 12 times 3 halves? That's going to be 18. You can either take 12 times 3, which is 36, and divide 2, which is 18, or you can take 12 divided by 2, which is 6, times 3 equals 18. And then this left-hand side will simplify. 4 divided by 2 is 2. 2 divided by 2 is 1. 2 times 9 is 18. So this side, this part of the solution, m equals 3 halves, that checks. And now we'll check 1. So we want to know, does 2 times 1 plus 1 times 1 plus 3, does that equal 12 times 1? So 2 times 1 is 2, plus 1 is 3. 1 plus 3 is 4. And 12 times 1 is 12. Again, we want to know, are these two sides equal? And we do end up with 12 equals 12, verifying our second solution. So the solution to 2m plus 1 times m plus 3 equals 12m is m equals 3 halves, or m equals 1.